This video is about how to solve exponential equations by getting the bases together. So you have these two steps up here. The first step in order to solve exponential equations is get bases together, or to be the same, using exponents. And then once you get the bases together, you set your exponents equal to each other. So we'll talk about that. So if I look at this, here's my first equation. Notice my base of 5 and I have a base of 5. That's already the exact same thing. So since my bases are the exact same thing, that means my exponents also have to be the same if these two are equal. So what I do is I set x equal to -3, solve that equation, which is done, and there is my answer. That's pretty basic. Because if 5x is supposed to equal 5 raised to the -3rd, if my bases are the same, then my exponents also have to be the same. So then if I look at this second one, notice 2 and 2, my bases are the same. That means that x has to equal 3x minus 4. My exponents also need to be the same. So I have this equation, go back to Algebra 1, solve for x, subtract 3x from both sides. I get -2x equals -4. Divide the -2 over, and I get x equals 2. And that is my final answer. Okay? This one's a little different because notice we don't have bases that are the same. I have a base of a 2 and a base of a 4. So what I have to do is I have to manipulate this so that my bases are the same. I can't do anything with 2, but I can rewrite 4 using 2 squared. So I have 2 squared, and then I leave this as 2 raised to the 3x minus 5. Notice my bases are the exact same now. That means the exponent of 3x minus 5 has to equal 2. Now I solve that equation for x, add the 5 to the other side. 3x equals 7. Divide both sides by 3, and you get x equals 7 over 3, and that is my final answer. Okay, let's go to the next slide here. So notice I have a couple equations that are very similar, but notice I have a base of 5 and a base of 125. I can't really do anything with 5, but I can rewrite 125 using exponents. I would make that 5 raised to the 3rd power. And if you don't know, just do trial and error. Okay? Bases are the same. That means 2x plus 1 has to equal 3. Subtract 1 from both sides. 2x equals 2. Divide x equals 1. There's my final answer. Okay? Go to the second one here. 8 raised to the 3x equals 2 raised to the 4x minus 7. I can't do anything with the 2, but I can rewrite 8 because 8 is 2 to the 3rd power. Now notice I'm going to put that in parentheses. The reason why is because this 8 is also being raised to the 3x. So this right here in parentheses is the 8, but it's still being raised to the 3x. Okay? So now what we're going to have to do is we're going to have to look at our exponent rules from Algebra 1. When you have a power raised to another exponent, power to a power, you multiply those exponents. So this becomes 2 raised to the 9x equals 2 raised to the 4x minus 7. Notice the bases are the same. Set your exponents equal to each other, and you get 9x equals 4x minus 7. Subtract the 4 to the other side. Getting ahead of myself here. So I get 5x equals -7. Divide by 5, and I get x equals -7 over 5. And that would be my final answer. Okay? Now if I look at the third one, okay, the third one's a little trickier because I can't take 27 and rewrite it using a 9, but I can rewrite 27 as 3 to the 3rd. 3 times 3 times 3 is 27. That also means that 3 squared is 9. So notice I changed both bases in order to make them work, and then that's to the exponent of 2x minus 5. So this parenthesis right here is 3x squared. That's the 9. And then the 2x minus 5 just drops down. But then I have a power raised to another power. I have to multiply those, and it becomes 3 raised to the 4x minus 10 equals 3 to the 3rd. Bases are now the same. Set your exponents equal to each other and solve. Add the 10 over, so I get 4x equals 13. Divide, and I get x equals 13 over 4. And there's that answer. Okay? Last slide. Okay. So the last slide is there's kind of a trick here. 4, we can rewrite that as 2 squared. The problem is I can't really do a whole lot with this 1. There is a trick. You can make that 1 4 to the 0 power. Our exponent rules from algebra 1. Anything to the 0 power is 1, and I can rewrite this 4 to the 3x minus 5. That means 3x minus 5 is equal to 0. Add the 5 over, divide by 3, and I get x equals 5/3. Okay. Next one, I need to rewrite 8 and 32 with the same base. I can rewrite 8 as 2 cubed raised to the 3x minus 2, and I can rewrite 32 as 2 to the 5th power. And then I have x minus 6. Exponent to an exponent, this is going to become 2 raised to the 9x minus 6 equals 2 to the 5x minus 30. Distribute that 5 in, distribute the 3 in. Set your exponents equal to each other and solve that equation. So what I'm going to do is I'm going to add 6 to both sides by moving the 6 to the right, and I'm going to move the 5x to the left, and I'm going to get 4x equals negative 24, divide by 4, and I'm going to get x equals negative 6. There's that answer. Okay? And then the last example for today is we have 1/2. How do I deal with this fraction of 1/2? Well, I'm going to use exponents. One of my exponent rules says negative exponents means to divide. So instead of dividing by 2, I can rewrite that as 2 to the negative 1st power. I can move that 2 to the top, and then 1 times 2 to the negative 1st is still just 2 to the negative 1st. So 1/2 is the same thing as 2 to the negative 1st. And then I can rewrite 4 as 2 squared raised to the 3x minus 1. Distribute the 3 or the 2 into the 3 there, and I get 2 to the negative 1st equals 2 raised to the 6x minus 2. Exponents are the same, or bases are the same, so set exponents equal to each other. Add the 2 over. I get 1 equals 6x. Divide by 6, and I'm going to get x equals 1/6. And that is how you solve exponential equations using the same bases.